All right. Now we look at how to find the mean, variance, and standard deviation of the binomial distribution. And here we have the formulas for finding the mean, standard deviation, and variance for any probability distribution. So these formulas over here, 5.1, 5.3, and 5.4, these formulas will actually work with the binomial distribution, but over here, 5.6, 7, and 8, we have shortcut formulas. So if you want to, you can actually go ahead and use these formulas over here to calculate the mean, variance, and standard deviation of the binomial distribution, but it turns out that you will get the same numbers if you just use these formulas over here for the binomial distribution specifically. So we're going to be using these formulas. The mean of the binomial distribution is equal to n, which is the fixed number of trials, times p, which is the probability of a success. The variance is n times p, n the fixed number of trials, p the probability of a success, times q, which is 1 minus p, and then to find the standard deviation, we take the square root of the variance. Now I wanted to draw your attention to the range rule of thumb here, and the range rule of thumb basically says this. Range rule of thumb says that if we have our number line here with our mean set up in the middle, so we'll have this number line, and the mean will be in the middle here, mu. It says if you go two standard deviations to the right, which is the mean plus 2 sigma, and you go two standard deviations to the left, which is the mean minus 2 sigma. If you do this, then you're separating what are considered in the middle here the usual values. You're separating the usual values in the middle here from the unusual values on the outside. So any value on the outside here is unusual. Unusual. So basically, if we know the mean and the standard deviation, we know the cutoff points for usual and unusual values. All right, so here are some examples. This is number 6. It says finding the mean and standard deviation and usual values. In exercise 5 through 8, assume that the procedure yields a binomial distribution. So we can already assume that this is a binomial distribution with n trials and the probability of a success on one trial, p. Use the given value of n and p to find the mean and standard deviation, sigma. Also use a range rule of thumb to find the minimum usual value, which is mu minus 2 sigma, and the maximum usual value, which is mu plus 2 sigma. These two, this is the minimum usual value, this is the maximum usual value. Well, the first thing they want us to find is the mean. And if you remember from the formula, the mean is n times p, is given up here. The mean is n times p, formula 5.6. And in this case here, n is equal to 152, and p is equal to zero point 0.5. So that we can calculate the mean to be 76. So the mean of this binomial random variable is 76. Now we could also found the mean using the formula for any random variable if we had all the possible outcomes for x, which would in this case be 0 through 52, and we would also need all the probabilities of all those values for the random variable from 0 to 52. So this is a much more concise way of finding the mean. All right, now they also ask us to find the standard deviation. The standard deviation is the square root of n times p times q, which in our case, let's see, is going to be the square root of 152, 152 times zero point 0.5 times zero point 0.5, which is p, times another zero point 0.5, which is 1 minus p, or q. So let's see what we have there. We have the square root of 152 times zero point 0.5 times zero point 0.5, and we get 6.1, or actually this is about 6.2. So we found the mean and the standard deviation. The mean is 7.6. The standard deviation, or sorry, not 7.6, 76. The standard deviation is 6.2. So now we're going to find the minimum usual value, which is mu minus 2 sigma. And mu minus 2 sigma is going to be 76 minus 6.2 times 2, which gives us, let's see, 76 minus 6.2 times 2 yields 63.6. So this gives us 63.6. And the maximum usual value, which is mu plus 2 sigma, is going to equal, let's see, this is going to be, let's see, we have 76 plus 2 times 6.2. So we get 88.4. So the maximum usual value is 88.4. All right, now let's see. That's how you answer a question such as that one. But let's take a look at this one here, where we're not asked explicitly to calculate the minimum and maximum usual value, but it's implied that that's what we need to find. It says, in a test of Y-sort method of gender selection, 152 babies are born to couples trying to have baby boys. So they're trying to have a baby boy. And 127 of those babies are boys. All right, so part A says, if the gender selection method has no effect and boys and girls are equally likely, find the standard deviation and the mean for the number of boys born in 152 babies. So what we're saying here is we're calling a success having a boy, and we're calling a failure having a girl. And the probability of having a boy, P, is going to be 0.5. And the probability of having a girl, Q, is going to be 1 minus 0.5, which is also 0.5. And let's see, N is equal to, well, 152 babies born, and then X is equal to 127. So I have all these numbers here. Let's see. Um, Part A says to find the mean and standard deviation for the 152, for the number of boys born out of the 152. So A is the mean and standard deviation. Well, the mean is going to be N times P, which is going to be 152 times zero point 0.5. And we've already calculated this as 76. So the mean, if this were completely random, would be 76 boys. That would be the average. And the standard deviation, we already saw, the standard deviation was 6.2. So part A, we've already done in the previous example. Part B. Part B, is the result of 121 boys unusual? Well, we had the minimum usual value, mu minus 2 sigma. We found out that that was actually, what do we say that was, 63.6? 63.6. This is the minimum usual value. And we also have the maximum usual value. And the maximum usual value is mu plus 2 sigma. And we said mu plus 2 sigma, we said was what, 88.4? 88.4, which is the max usual value. All right, so basically our number, which is 172 for x, 172, x of 172 falls well without the outside of this range. What we're saying is that the usual values fall between 63.6 and 88.4, and where the mean is in the middle here, which is the mean we said was what, 76. This is mu right here. This is a mean. This is mu plus 2 sigma, and this is mu minus 2 sigma. All right, so we have mu minus 2 sigma and mu plus 2 sigma. And outside of this range, we have unusual values. The value that we got was 127, way out here, 127. This was the x value that we had. And this x value is well outside of the range of usual values. So the usual values are in here, and we're well outside of that range. So therefore, having 127 babies would be unusual because it's well outside of the values of the range of usual values.